All right, we're going to jump into lesson 11.2, which is solve linear systems by substitution. And this is just another method that we can use to solve our linear systems. In the last lesson, we looked at solving by graphing, right? And we were figuring out where the solution was based on where the two lines intersected, or if they intersected. And this is just a different way to do it without graphing, and we can do it algebraically. So we'll start with some steps here. And these steps are kind of summarized, so I'll just talk through them here. It says isolate one variable from either equation. So we need something to be isolated, either x or y from one of the equations. And then we're going to substitute into the other equation and solve for a variable. So we're basically solving one at a time. We're going to find x first and then y, or we can find y first and then x. And so let's take a look at what that looks like here on the first one. It says solve the linear system by substitution. So remember, the first step is to get something isolated. So looking at my two equations here, I want to figure out, okay, what's going to be the easiest variable to get by itself? And it looks like this y would be easiest to get by itself because it doesn't have a coefficient, right? It's just a lone y. It's only going to require one step to get by itself. And so I'm going to go ahead and subtract 3x to get it by itself, which would then give me negative 3x on this side, and my equation would look like this: y equals negative 3x plus 9. And so now I have these two equations. I have this top one, which I haven't touched, and I have this bottom one, which I just rearranged to get something by itself. So we always need to start by getting a variable by itself. And now I'm going to set these up side by side. This is just for organization. You don't have to do it like this, but I think it's helpful. I'm going to write my top equation, which is negative 4x plus 3y equals 1. Okay, and then I'm going to write the other equation that I just rewrote to get y by itself, which is y equals negative 3x plus 9. And so now that we have one of these isolated here, I have this y isolated. What I'm going to do is I'm going to take this thing that y equals, it equals negative 3x plus 9. I'm going to take that and I'm going to plug it in for y because that's what y equals in my other equation. So I'm basically substituting this whole expression in for y because that's what y equals. So it's going to look like this. We're going to have negative 4x plus 3, and then instead of y, I'm going to plug in what I have here, which is negative 3x plus 9, and that equals 1. So notice I replaced y with what y equals, which is negative 3x plus 9. And now I can solve this equation, so it's going to be some distribution that I've got to do here, right? Distributing this 3, so I'm going to end up with negative 4x minus 9x plus 27, and that equals 1. And then I'm going to combine like terms, so that's going to be negative 13x plus 27 equals 1. Subtract 27 to the other side, so that's going to give me negative 13x equals negative 26. And then I need to divide both sides by negative 13, so I'm going to end up with x equals positive 2. And so that's one answer that we have, is x equals positive 2, but that's only half of the answer for this system, because remember, it needs an x and a y. So now what I'm going to do is I'm going to take this information, this x value that I just found, plug it in for x, and then solve for y here. So it's going to look like this. I'm going to say y equals negative 3, and then instead of x, I'm going to punch in 2 plus 9, and then I'm going to solve here, so y equals negative 6 plus 9, which means that y equals positive 3. And so I have the other half of my equation there, and so my final answer should always be an xy ordered pair. So I'll go ahead and write that final answer here, which is just one solution, and that solution is going to be at x comma y, which is 2 comma 3. All right, and that's one solution. So if we were to graph these, then they would intersect at that point, right? That would be another way we could do it, but we're doing algebraically right now. All right, I'm going to move on to the next one here. Okay, and we're going to follow those same steps. So first we need to get something by itself, whatever looks like it's going to be the easiest to isolate. In this case, I think x is going to be the easiest to get by itself because all I have to do is get rid of that 2y there. And so I'm going to go ahead and start by doing that. To get that by itself, I'm going to subtract 2y. And that's going to give me this equation here, x equals negative 2y and a positive 2. And so now I have these two equations here. I have the top one, which I haven't touched, and I have this one, which I just rearranged so that one of the variables would be by itself. And now I'm going to slide over and set them up side by side here. Remember, this part's just for organization. You don't have to do it like this. So I'm going to get 7x minus 3y equals negative 20. And my other equation is x equals negative 2y plus 2. Okay, so this one's a little bit different, right? Because in this case, I have x equals instead of y equals. So I'm going to take this expression here, and I'm going to plug it in for x, because that's what x equals. So I'm replacing x here, not y, because I have an x equals. So it's going to look like this. We're going to have 7, so notice that 7 stays where it is. And then instead of x, I'm going to put negative 2y plus 2 minus 3y equals negative 20. So once again, I took this piece here, negative 2y plus 2, and I replaced x with it. And so now we only have y's on our equation on the left side, so I'm going to go ahead and solve that there. So it's going to require some distribution. So we're going to end up here with negative 14y plus 14 minus 3y equals negative 20. I'm going to combine my y-like terms there. That's going to be negative 17y plus 14 equals negative 20. Subtract 14 to the other side. So I get negative 17y equals negative 34. And then divide both sides by negative 17, and I get y equals positive 2. And that's half of my answer there, right? I'm going to take this, I'm going to plug it in for y into my other equation here and solve for x. So I get x equals negative 2. Instead of y, I'm plugging in what I found, which was positive 2, and then plus 2. So I get x equals negative 4 plus 2. That means x equals negative 2, and that's the other half of my answer here. And so then my final answer I can rewrite as x comma y, which in this case is going to be negative 2 comma positive 2. Remember, always x first and then y, and that would be my one solution there. All right, we'll keep going here to the next one. Same idea, I got to figure out, okay, what's going to be the easiest to get by itself. In this case, I think the easiest to get by itself is going to be that top equation, right? Because we have this x that doesn't have a coefficient, and to get it by itself, all I need to do is move over this negative 3y to the other side. So that's going to look like this. X equals, when I add 3y to the other side, so it's positive 3y plus 5. And so now I have these two equations, right? This top one here that I just rearranged and the bottom one that I haven't touched yet. And now I can go ahead and set them up side by side. And so I have x equals 3y plus 5. And my other equation is negative 2x plus 6y equals negative 10. All right, and now I'm going to go ahead and use my substitution. So in this case, again, we have x equals something. So I'm going to take this, whatever x equals, and I'm going to plug it into my other equation for x. And so it's going to look like this. -2. Instead of x, I'm replacing it with what x equals, which is 3y plus 5. And then I have plus 6y equals -10. And now I'm going to go ahead and solve this, starting with some distribution. And so we end up with -6y plus, nope, that's going to be -10 plus 6y equals -10. And so we're going to see what's going to happen here is these are going to cancel out, right? Because -6y and +6y, those cancel out, and they're just leaving me with -10 equals -10. Okay, we've seen something like this before. If all my variables cancel out, then I have two options, either no solution or infinitely many solutions. So we decide, is this true or false? Well, this is a true statement because -10 does equal -10, which means that I have infinitely many solutions. And if you were to graph this, hopefully you remember that that means that these two lines would just be laying on top of each other. All right, we'll keep it moving to the next one here. Same idea, we got to solve this by substitution, and it doesn't really look like anything is going to be easy to get by itself here, right? So I'm going to have to do some work here. I'm going to go ahead and pick a variable. You can pick anything that you want to isolate. I'm going to go ahead and pick this x and try to get that x by itself. So I'm going to move this equation over so I can work with it. 2x plus 6y equals 58, and I'm trying to get x by itself, but you can pick anything. So to get x by itself, I would subtract 6y. That would give me 2x equals -6y plus 58. And then divide everything by 2. Okay, and I'm going to get x equals -3y plus, okay, we got to do 58 divided by 2, so some quick mental math there. We end up with 29. And so now we have these two equations, right? We have this one where we just isolated x, and we have this bottom equation, which we haven't touched yet. And I'm going to set them up side by side now. And so I've got x equals -3y plus 29. And I've got 3x minus 5y equals -53, which I still haven't touched. Okay, and then once again, since this is what x equals, I'm going to go ahead and plug that in for x in the other equation. So it's going to look like this. 3, instead of x, I have -3y plus 29 minus 5y equals -53. Going to start with some distribution here, so I get -9y plus, okay, this is going to give me something pretty big here, so that's going to be, let's see, 87 minus 5y equals -53. Combine my like terms, that's going to be -14y plus 87 equals -53. Then I'm going to subtract 87 to the other side. So I get -14y equals, this might be some mental math here, maybe some calculator work. So -53 minus 87 gives me a 140, -140, which is going to be nice because then I divide both sides by -14 and I get y equals +10. And so we've got half of my answer there as +10. And I'm going to take that and plug it into the other side. And so I have x equals -3 And then I'm going to plug in this 10 plus 29. And so we get x equals negative 30 plus 29. So x equals negative 1. That's the second half there. Okay, and then I can go ahead and write my final answer, which is always going to be x comma y as an ordered pair there, which in this case is going to be negative 1 comma 10. All right, last one here, we'll shoot down to the word problem. We've got the movie theater sells popcorn and fountain drinks. Brett buys 1 popcorn bucket and 3 fountain drinks for his family, which costs him $24.50. Sarah buys 3 popcorn and 4 drinks, which costs $39.75. They've got the equations set up for me here, right? So they've got the system, 2 equations, 2 variables. That's the system of equations. They've got that set up down below, and I'm going to solve it using substitution. So I need one of these variables to be isolated. Notice the p there is already by itself. I just need to get rid of this 3d, which I'm going to do by subtracting to the other side. So I'm going to subtract this 3d from both sides, and I'm going to end up with the equation that looks like this. 24.5 minus 3d, because I'm subtracting it from both sides, equals p. And then my other equation is going to be 39.75 equals 3p plus 4d. And so now I have this p variable by itself, so I can take this expression here and plug it in for p in my other equation. So I'll go ahead and do that. And we're going to end up with 39.75 equals 3. Instead of p, we're going to have 24.50. 24.5 minus 3d plus 4d. Okay, so that's going to require some distribution there. So we're going to end up with 39.75 equals 3 times 24.5. It's going to give me 73.50. Okay, so 73.5 minus 9d plus 4d. Combine my like terms there. Negative 9d plus 4d is negative 5d. Okay, then I got to get rid of this 73, so subtract it to the other side. So we're going to end up with 39.75 minus 73.5, which gives me negative 33.75. And that equals negative 5d, and then I'm going to divide that by negative 5. And I get d equals 6.75. Okay, and so we've got the first part of our answer here, which is d equals 6.75. So that's going to be the cost of the drinks, right? And then we'll go ahead and find the cost of the popcorn by taking this and plugging it in to my other equation here for d. And so we're going to end up here with 24.5 minus 3 times 6.75 equals p. I got to do 3 times 6.75, which gives me 20.25. So 24.5 minus 20.25 4.25 equals P. And then I can just go ahead and subtract that there, and that's going to leave me with P equals 4.25. And we're talking about money for these items here, and that's going to be the cost of the popcorn. So same process, right? We're just finding it in this context of this problem, but the same process of isolating a variable and then plugging it into the other equation. All right, thanks for watching.